Hi and a very good morning. My name is Ellyana binti Khairil Faizi. My metric number is 24303238. My group is T5A and my partner's name is Mohammad Sofran bin Jaafar. So today I would like to do a Viva regarding projectile motion experiment. So the overview for this experiment is that in this experiment, we will study regarding the 2D projectile motion using Viva's projectile motion ballistic unit. So one of the things that we did is to represent this projectile is by using a steel ball that is launched at the various bias spring at different velocity and also at the different angles, which is 25, 35, 45, 55, and also 65 degree. So for every launch, we have recorded the range S, the maximum height h, and also the experimental initial speed. So once we have collected the data, we compare the experimental and also the theoretical values. We investigate the relationship between the range, the height of projection, the angle of projection, and also the initial speed of the projectile. And last but not least, we also use this result to estimate the gravitational acceleration g. For the first question, what do you think is the best angle of projection to start the experiment with? So we should start the experiment at 45 degrees. This is because the maximum horizontal range for our projectile can be reached at the 45 degree for any given initial speed. Therefore, when we start the angle with 45 degree, it gives a clear, large ranges that are easy to measure and compare to theory. So on the right side, this is how we get the value of 45 degree. So by using the maximum horizontal range, r is equal to v naught square sine 2 theta over g. Then we use sine 2 theta is equal to 1. Why? Because it is the highest value. So we rearrange back this equation, so we get 45 degrees. So we should start this experiment with 45 degrees. For the second question, suggest a way to accurately measure the height of projection of the steel ball in this experiment. So firstly, we can measure the height of projection by placing a vertical meter ruler next to the projectile. Then, we observe the highest visible point of the projectile by using a video or even a repeated shots. We have to make sure that the ruler is the same plane as the projectile in order to avoid parallax error. And lastly, we should repeat this step at least 3 to 5 times in order to reduce the random errors. For question C, suggest a way to determine the time taken for the projectile in this experiment to reach the maximum height. So in order to calculate the time, the maximum height can be found by using the vertical component of initial velocity. This is because at the maximum height, the velocity will become zero. So firstly, we can use the equation of an actual initial speed from this experiment, which is v naught equal to v square experiment plus gd sin theta, where the v naught is the initial velocity, the v square experiment is the velocity for this experiment, g is the gravitational acceleration, d is the distance between two sensors, and theta is the angle, it's the launch angle. So next, we split into the vertical component, the initial velocity vy is equal to v naught sin theta. Then, by using the kinematic equation, v final equal to v initial minus gt. So, since we have to calculate the time at the maximum height, therefore our final velocity will become zero. So, we substitute back the final velocity equal to zero in the kinematic equation. Then we get 0 equal to v naught sin theta minus gt. Then we rearrange back the formula until t become the subject. So, t top is equal to v naught sin theta over g. Then, we substitute back this equation into the actual initial speed of the experiment, which is the first equation. Then we get t is equal to sin theta over g square root v square experiment plus gd sin theta. For question D, from the theoretical physics point of view, will the type of material of the ball affect the range and height of projection? Why and why not? So theoretically, no. This is because in projectile motion, the formulas that we use in order to calculate the range and height only depend on initial velocity, v naught, angle, theta, and also gravity g. So as you can see from the right side, the formula that we use to calculate the maximum height, v naught square in bracket sine theta square over g, and also the range which is v naught square sine 2 theta over g. So in both of these formula, the mass or the material does not appear in the equation. Therefore, both steel and wooden balls should have traveled in the same motion. For the last question, explain why in the real experiments performed, there are still significant discrepancies in the range and height of the projection obtained using steel and wooden ball. This is because in our real experiment, the results differ due to the presence of air resistance, density, surface roughness, and also launcher contact. So all of these factors will affect the motion. A steel ball is much more heavier and smoother. Therefore, the air resistance slows it down less than a wooden ball. So, steel balls generally give results closer to the theory. So the first thing that affect the wooden ball is the air drag effect. The wooden ball loses more speed because it is more lighter. Therefore, it will produce a greater deceleration. Next, the wooden ball have a surface roughness. Therefore, it will increase the drag. And lastly, wooden balls may gain uneven speed. Therefore, the range will be changes. With that, I have reached the end of my presentation. Thank you for your attention.